We did have an early morning liftoff. We were in the dark up right until just about liftoff time, and the photography that you see here shows looks more like a night launch than a day launch. Actually, we were able to see some of the early indications of dawn just about the time of ignition. We did take off through some clouds, and as we passed through those clouds, it really was spectacular, more so than I had imagined it would be. The clouds reflected the exhaust plumes and exhaust colors from the solid and the liquid engines, and turned the whole area a very bright orange-pink color, just very similar to the hue that forms around the airplane or around the vehicle during the ionization period of re-entry. This series of pictures was put together sequentially by Don Picard here, and I think it really is a beautiful set of pictures. I think he did a great job of putting this series together. This particular one you're looking at now is taken from a helicopter. You can see the helicopter blades rotating there at the top of the picture. The first thing when you get on orbit, there's an awful lot of work to do, and it's a terrible temptation to keep from running over to the window and spending your time looking out at the world. That was Africa that we looked at. Very quick crew introduction as we go around. This is Dick Covey. Dick's colonel in the Air Force, graduate of the Air Force Academy from Florida. Mike Lounge, former Navy flyer, is now with the Air National Guard here in Texas, a lieutenant colonel. Worked the arm superbly. Bill Fisher, who is a medical doctor practicing emergency medicine in the area here, and one of our EVA types who got himself prepared physically to go out and wrestle this thing around. And, of course, Ox Van Hoften, who's also in the Guard here, a lieutenant colonel, a former Navy pilot, and was our other EVA.
This is early in the flight. We had a little problem with a mechanical hang-up of the sun shield that covered OSAT that made day one a little more exciting than we had planned. I took the remote manipulator arm out of its cradle and used it to gently tap this sun shield off the satellite and pushed it back out of the way so that we could deploy the satellite. In the process of this, we discovered that the elbow joint was not functioning properly under primary power, and so I had to use the arm one joint at a time rather than in the computer augmented mode. I thought that was not a fair malfunction to throw in, but it all worked out. We got on the timeline here and got OSAT inspected, decided it was healthy. The ground gave us a go for deploy, and here you see it leaving the payload bay. This is about 8 hours into the flight. The OSAT spacecraft there with the cylindrical shape and the gray spherical shape on the bottom, the PAM, payload apogee motor that boosts the satellite on up to geosynchronous orbit.
We hadn't planned on deploying 2 satellites on the first day, but this wasn't a normal first day, and we got the word from the ground that we were also going to deploy the ASC satellite, which you see here. Ox remarked it looked like a bad amusement park ride, and it really did going out. It was amazing to us that it spun as perfectly as it did, but every aspect of that deploy was nominal, and I think our words to date are that both satellites are functioning perfectly in geosynchronous orbit.
Since we did a large part of our first 2 days planned work on the first day, the second day was left to getting ready for the rest of the mission, and also gave us some time to start doing our Earth observations. One of our favorite modes is what we call the glass bottom boat mode, where we could, a couple of guys could sit up looking out the overhead and back windows and take pictures. This shows the eastern coast of Australia. We saw lots of Australia and lots of southern Africa and lots of South America as the land masses on our flight. Starting from the first day on, there was always somebody in the window with a camera. There's a great deal of both our entertainment and our work. This is another shot of Typhoon Pat and some of Bora Bora and the Society Islands in Polynesia.
There's usually a pretty good fight for window space up there. When we had the chance to do it, we always jumped in to do it, and I think stealing Covey's lines here, but this is the one shot we had of Hurricane Elena in the daytime. We, on the third day, got back into the satellite launching mode, and this was the SYNCOM F4, the fourth in a series of satellites. gave us a good opportunity to look at it up close, see how big it really was, and it was impressive coming out of the orbiter. It's a very large satellite. It gave us an opportunity as well to get an idea of what the station keeping would look like. It comes out at about 1.7 RPM, and at this point looked real good to us. The sequence it goes through at 80 seconds, the antenna, the Omni antenna on top is supposed to rise, and this is what didn't happen on the one that we went to repair. So we were, of course, eagerly awaiting the antenna coming up, and of course we're overjoyed when it did. There's a sequence here at 80 seconds when the antenna rises up. After this, at 6 minutes, the satellite goes into its spin-up mode. We were able to observe all of that, and we're able to observe it all the way up to the 33 RPM as we backed away from it. And then it's deployed against the Earth or with our payload bay down, so all of our pictures end up down against the oceans.
All the electrical hardware that we were to use in repairing the satellite was checked out on day 2. I'm here checking out the spun bypass unit that you see flashing on the wall there. That was the one that was actually attached to the satellite and enabled us to give the ground control of it. And prior to any planned EVA, we always check out the suits and make sure they're functioning as they should. And here you see Mike and Ox and I checking out the suit. That's the display we see in the caution and warning system flashing in front there. And the suit's checked out just fine.
The rendezvous for joining up with the CENTCOM satellite went extremely nominally. We see Joe flying the spacecraft in here through the 1,000-foot point at a closure rate of 1.5 foot per second, which was our braking gate at that point. We were very fortunate to have good ground support on the rendezvous. Our first sensor pass with from the orbiter showed that the error was only 182 feet off in the locations between where we thought we were and where we thought the satellite was. We were very pleased with that. And Joe was able to bring the CENTCOM satellite right on into the payload bay.
Once we went outside, of course, this just demonstrates that we're half time in the dark and half time in the day. We went outside at night to set up the platforms that fish could work on. We had these little lights on our helmet that gave us some additional light, and had 2 or 3 lights out in the payload bay. After this, I went off and got onto the end of the arm on the manipulator foot restraint, preparing to approach the satellite and see how we could get hold of it. We were somewhat limited in the fact that we had this single joint operations on the arm, and the satellite was not quite exactly where we wanted it to be, but we found out that that using some of the devices that we had worked on the ground, you could get a good idea about how it would handle, and it handled about like we thought. You can see here when I had spun it around, and this was getting hold of the side that we wanted to attach the capture bar to. You can see a little bit of how it is to handle that thing. It's big and bulky and massive, of course, and probably the hard part about maneuvering is you can't see very well. It's kind of like staring into your house here, moving it around. It's very big, but it was manageable.
Once Ox got a hold of it, we very carefully maneuvered it forward and down to Bill, and Bill attached this handling bar so he could manage it, while Ox, on the other end, took off the capture bar and attached the bar that had a grapple fixture that was compatible with the remote manipulator system. As soon as he gets this tight, I will take him down. Ox will get out of the MFR and take the MFR off of the arm, and then I went back up overhead. This wasn't how I planned to do the grapple, single joint, but we felt that once Fish had a hold of it there in his foot restraints, we wanted him to keep a hold of it. And I could see the tip of the grapple fixture there in the center of that window, and I just brought the end effector down over it and kind of stabbed it. And I knew that once I got the can over that pin, once I commanded a capture, that it would be securely in there. Once we got it on the end of the arm, then it was just a matter of taking and presenting the various work sites to Bill for the repair work that he had to do.
And that went pretty well. Mike was able to get the positions that I needed just as I had trained for them to be in. We attached the electrical connections that were needed and expected. We were able to then attach the spun bypass unit that you saw me checking out. That was the first time we had any indication that the satellite was really alive, and the first good indication we had that our repair was going to work. We had evidence of good battery function in the satellite. Here you can see the reflection of the orbiter as Ox is helping me configure a tool board onto my tool stand. And again, much of the work we did with the SBU, or spun bypass unit, was in the dark. That was a little bit different than I'd expected, but it didn't prove much of a problem. The spun bypass unit attached just like it had when we went out to Hughes and tried attaching it on the F5 Syncom that they had out there. It really went quite well. Here we're attaching the unit itself to the satellite, and that's the device that has the timers in it that we later threw at the end of the mission to activate the delayed sequencer that is now operational and enables Hughes to command the satellite. After that, Mike turned the satellite around to what we call the D-spun position, working on the top of the satellite, and it was there that we made the required electrical connections with our relay power unit, which enabled us to fire the squibs necessary to deploy the Omni antenna. And I don't think I really expected this to work, but it did. And that fella came up, and I was really excited about it. It worked a little slower than they than the other one did, but that's temperature dependent. And after the Omni had deployed, everything looked real good to us on board. That the repair was, at least our part of the repair, was going to work and work well.
After we completed EVA, we still had some more things on board. This was a experiment, a material processing experiment from 3M that had a little bit of difficulty in the beginning of the mission, but we were able to process all 9 of their cells on board, and it was kind of a fun little diversion. We also had meals 3 times a day. Meals are not quite like they're on the ground, but you've probably seen pictures of these before. It's just you can sit in the roof or the floor or wherever you want, and we always ate our meals together as much as we could. It's just a good way to keep together and figure out what each one of us is doing.
We also did some physics experiments on the fly. That was a little drop of water. We were watching how the dynamics work on that. We tried the same thing here again with apple juice. You can see how the bubbles tend to, inside the fluid, tend to stay separated, and that's some of the problems we occasionally have with gas in our food. Here's the old ox grouper grabbing that guy. And we got ready for the second EVA the next day. It was really a pretty relaxed timeline getting ready for that, and Ox and Fish were raring to go.
Outside, we had to reset the workstation because we took everything apart after the first EVA in case something happened, forcing us to come home. Now we're putting the tool stand back up there because the task we had yet to do was to install the new nozzle cover on the nozzle, which contained within it a transmitter which would let Hughes know what the temperature of the solid rocket motor was, and that was critical data for them to determine when they'd be ready to fire it. I was putting on here little clips onto the nozzle that enabled me to then attach the nozzle cover to the bottom of the satellite. And shortly after that, we removed the safe and arm pins from the what we call the 0 and 180 degree positions. And after that, the timers were thrown, and Ox was ready to get back in the MFR and go ahead and spin this fellow up.
Once we got back on the arm, it just kind of reverse scenario of the way we got it back down there. We passed it back to where Fish took off his handling bar, and I got hold of it up on top, maneuvered it into the predetermined launch position, and probably the spin up was one of the easier parts of the whole thing. Mike got a good documentation of all this. This is the first push here. We found that the arm was a lot stiffer than I had originally thought. We tested this in the payload bay, and we're able to, I think I got a good 1 RPM here on the first push, which meant it's probably about 50 to 60 pounds of push on it. We planned about 10 pounds, is what we thought the arm would be good for. And I got four pushes on it total, which was put it up higher than we had planned or higher than we needed it to be. Hughes was interested in getting it anywhere from 2 to 10 RPM. I believe we ended up at about 2.8. We could have stayed there and continued, but we decided that things were looking so good, let's not try to make it better. This was the second one. The first and the last one were about the best, but you can see we were real pleased that the attitude of it looked real good. It was not coning, which is the one thing that we'd concerned ourselves the most with. It was spinning very regularly. Again, Joe was doing a great job of keeping me right in there to get it when I came by again. You just reach out and give it another push. You can see the orbiter. Every time you push on it, it would move away from you at a small, about 0.2 of a foot per second. The orbiter had to make that up, and we got it every single time it went by. So it was we were real pleased with that. This is the last one. It's going now a little bit over 2 RPM. I got a real good push on this one. You can see the arm bounce on these things every time you'd get hold of it. Get one little push goodbye, and we quit chasing it, and then you can see it now separating away from the orbiter. It looked in excellent condition. The only thing we left with it were those electronic boxes, and we left this 5-pound spin-up bar on it. About this time, took one look back at it and couldn't reach around to pat myself on the back, so we were all pretty pleased with it here, though. That was a lot of fun.
Any mission this complex and with this kind of a job, you know, Sox didn't have any coning on the SYNCOM. He had a lot of practice as we were getting ready for it. While we were on orbit, while we were in zero gravity, Fish is getting the SYNCOM simulator treatment. The last push-off, you'll notice, we didn't get any coning on SYNCOM, but he got a little coning on Fish on this last one in the wall there. Mission this complex requires strict discipline, and fortunately we had a well-disciplined crew. Of course, you know, you take 4 guys off the farm, some of them are able to respond a little quicker and learn a little faster than others to military movements, and some guys just never learn.
That's crazy.
I'm not doing any more parades.
We did have a drill team, crack drill team here that we practiced every morning. Zero gravity's got to be fun. If you hadn't noticed or picked up on it by now, it just is a great deal of fun. And while we were airborne, we took off with 5 guys, and we picked up a 6th crew member on board and decided that the only fair thing to do was to include him in a crew portrait. So we piled around this guy. The morning of landing actually was a typical Edwards day. It was a good, clear day. We could see very well. The wind was blowing about 20 knots, and it was a little dark when we came in. It was dark during the entire entry until we got just about to the Edwards area and the sun came up over the horizon. We could see the ground from the cone, from the high-altitude approach cone, but it wasn't until we were in final approach that we could really pick out the details of the lake bed and pick up the aim point and then go ahead and settle in for landing. This is kind of a neat series of pictures coming through the skyline. You notice it started out blue and it's turning to kind of the pink glow of the early morning dawn. There was no turbulence. It was really a beautiful morning to land an airplane out at Edwards. Dick made superb calls, altitude airspeed calls, which allowed me just to concentrate on flying the airplane and not worry about how the energy was coming out. And we landed on Lake Bed runway 23, which we've landed on previously with the program. We had, with that wind, we had a fairly short rollout, about 6,100 foot, I believe it was, rollout distance. We used moderate braking, and to date, at least, we have not learned of any damage that was done to the brake system. I think we also felt, as a crew, we felt about as good as any crew, I think, has after landing. We recovered, readapted to 1G very rapidly, felt good, ran around, looked at the airplane, found very little damage on the airplane. I think to summarize the mission, I think it's fair to say that I feel anyway that it was just a tremendous team effort.